In this lecture, we are going to study about the types of polarizations. Unit 5, Lecture 2. Now, we have already seen in the previous lecture what is polarization. Polarization is the process of producing electric dipoles which are oriented along the field direction is called polarization in dielectrics. What is polarization vector? The dipole moment per unit volume of the dielectric material is called polarization vector P, given by mu by V and measured in coulomb per meter square. So in simpler words, what do you understand by polarization? The displacement of positive and negative charges in a solid by the application of electric field leads to polarization. P is proportional to E, or P is equal to alpha times E, where alpha is the polarizability. If the solid contains n number of particles per unit volume, then P is equal to n alpha E. Now, polarization occurs due to several atomic mechanisms. When the specimen is placed inside an electric field, mainly three types of polarizations are possible. These are electronic polarization, ionic polarization, also called as atomic polarization. Third one is orientational polarization, also called as dipolar polarization. So we shall see something about each type of polarization. The first one is electronic polarization. What is electronic polarization? Electronic polarization occurs due to the displacement of electron cloud of each atom with respect to its nucleus in the presence of electric field. This creates an electric dipole in the dielectric. So initially, when you take an atom, the center of positive charge and center of negative charge will be acting at the same point. Only when you apply an external electrical field, then what will happen? The center of positive charge and center of negative charge will separate, leading to a dipole. The induced dipole moment mu is equal to alpha E times capital E, where alpha E is the electronic polarizability. Electronic polarizability is proportional to the volume of atoms. Now, this polarization is independent of temperature. It does not depend upon temperature. In this diagram, it gives you a clear picture. If you take an atom with the nucleus at the center and the electron cloud around it, here there is no electrical field that is applied. So the center of positive charge is at the center. The center of all the negative charges, center of mass if you can call it, is acts at the center. So both acting at the same point, there is no distance between them, or dipole is not present. But when we apply an external electrical field, the center of positive charge and center of negative charge, there is a distance between them. This leads to a electric dipole and electronic polarization from there. Next, we shall see what is ionic or atomic polarization. In this diagram, you would see Na plus Cl minus. Already a dipole is existing. But if you take a Na plus, there's a Cl minus above, the Cl minus down and around it. So the total dipole moment may be equal to 0. Now what happens when you apply an external electrical field? The center of Na plus and Cl minus move away when you apply external electrical field, and they move to different extents. Like if Na plus moves x1 distance, Cl minus may move x2 because their masses are different. So once again, x1 and x2 are the displacements of the positive and the negative charges in ionic material. When an electric field is applied to an ionic crystal, the polarization that arises due to the displacement of positive ions away from the field and the displacement of the negative ion towards the field is known as ionic polarization. This type of polarization occurs in ionic molecules such as sodium chloride, potassium bromide, so on. So it's very clear that the amount by which they move will be different because the masses of the positive charge and the masses of the negative charges are different. Now, if x1 and x2 are the displacements of positive and negative ions in an ionic crystal, due to the application of electrical field E. Then dipole moment mu is equal to small e, the charge into the displacement. Displacement is x1 plus x2. In addition to ionic polarization, an ionic molecule also possesses electronic polarization due to the displacement of electron cloud. So, ionic polarization is present, also an electronic polarization is present within it. The next type of polarization is orientation or dipolar polarization. As you see in the diagram, H plus Cl minus, already a dipole is existing in its own direction. When you apply an external electrical field, what will happen to this dipole? This dipole will try and orient itself in the direction of the external fields. Now, the orientation or dipolar polarization is produced only in polar molecules like HCl, H2O and nitrobenzene. When an electric field is applied to a polar molecule, the dipole experiences a torque and try to align parallel to the applied field, which results in a rotation of the dipole. Orientation polarizability is inversely proportional to temperature. If the temperature is more, the polarizability will be less. In the first diagram, you would see over here that they are randomly oriented. They have a dipole, but they are all randomly oriented. In the second diagram here, you would see when you apply an electrical field, all the dipoles will try and orient themselves in the direction of the external field. So basically in this lecture, we have seen the types of polarization. What are the three types of polarization? The electronic polarization, ionic polarization and orientation polarization that we are having.